Greetings, everyone, and welcome back. So this is Mr. Brewer today, bringing you a lesson specifically on a new topic. It's actually going to be a review topic for most of you. This is probably something that each of you have seen before. So the topic today is going to be the metric system. So how about before we get started, a little quick joke, a little dad joke for you. What does a guy from the US say about a beautiful woman who knows the metric system? He says, boy, I'd really like to meet her. Never mind. Anyway, so for today, we have three very specific goals in mind. This is probably going to be a review for most of you, but I'd like you to come away with being able to deal with metric units in a more, I guess, efficient way, a quicker way to deal with things. So first goal for the day would be to identify the common symbols and units of measure. We're going to work with the ones that are common to the scientific world. I understand there will be others that exist. We're going to kind of stick to the ones that the scientific world kind of sees and uses. So even the ones that I post, some of them aren't really all that commonly used. Next thing we will take a look at would be to be able to compare one metric or international system unit. Sometimes the metric system is embraced and called the international system. We spoke about that in a previous lesson. And we'd like to be able to describe how many times smaller or larger one unit of measure is. For example, how many times smaller is a centimeter than a kilometer? So I'd like us to have some strategy for doing that. And then finally, convert between different metric units, take a centimeter amount and turn it into maybe like a millimeter amount. So those are the three very specific lessons. So here's where I think a good place to start is. This is an organization that I put together. I like to call it the metric staircase. And the metric staircase tells us a little information about how metric units are arranged. So you're familiar with metric units. Metric units have a prefix. The prefix changes the meaning of what we call a base unit. So if the base unit is something called meter, right? A meter has a very specific distance. It's from one end of this stick to the other. We can break meter down into smaller units by putting a prefix in front of it. Maybe we put centi in front of it and we break it down into smaller pieces. So we're familiar with the way that metric works. It uses a prefix word and then a base unit word. You marry it together, it becomes a new unit of measure. For example, centimeter, kilo, meter. Put those two together, it changes the amount. So we have generally three base units that are commonly used. Gram would be how heavy something is. So we could put any prefix in front of it that we see on here: giga, mega, tera, nano, milli, micro. We could do the same thing with meter or liter. That's the beauty of the metric system. It's consistent. The prefixes always mean the same thing, and it always relates to a factor of 10. So how many times do we use a factor of 10 relates to what the specific prefix is and what factor of 10 has been assigned to it. So we'll take a look at kind of how that works today. So in order to make this work, we need to be familiar with the symbols that represent each unit or each prefix. So giga represented by an uppercase G or capital G, mega, capital M. Kilo, it's typically a lowercase k. Some people might write it as an uppercase. Hecto, lowercase h. Deca, strange one, has the D and the A. Our base units: gram, lowercase g, meter, lowercase m, liter, usually written as uppercase L, otherwise it could be mistaken as an I. Deci, lowercase d, centi, lowercase c, milli, lowercase m. Micro is the strange one. It looks like a cursive U, but it's actually a Greek letter. It's a lowercase Greek letter called mu, mu. MU. You don't need to know that, but looks like a cursive U. It's actually Greek letter mu. Tera, uppercase T, a very large unit. Nano, a very small unit, right? Lowercase n. Pico, a very small unit. So what you're going to see is how this is arranged. It's arranged from an origin, a center, starting point where base is 0. And then we fall downward to the small units, right? Deci, centi, milli, micro. And these ones, nano and pico, would even go on here 3 spaces below. Micro would be nano, 3 spaces below that would be pico. there just wasn't room for us to kind of visibly see it well on here. So I put them over here to the left, other useful units. We could climb, go the other way, right? Now the exponents are positive. Positive exponent, exponent means it's larger than base unit. Smaller exponent, or negative exponent, means it is smaller than base unit. So -1, -2, -3. It doesn't necessarily mean a negative value. It means a factor of 10, but smaller, meaning divided by 10 instead of multiplied by 10. So it's kind of like the number of times we would divide by 10, because metric units or SI units relate to factors of 10. Okay, so let's put this into practice. First of all, in order to deal with this, we have to be able to recognize prefixes and recognize them when they're written in their typical measurement form. So for example, milligram, mg, milli next to gram. Don't confuse that lowercase m for meter, right? When it's just meter, we're going to see that there's only a one-letter symbol. I'll explain that in a moment. So micrometer, micro, right? Symbol next to meter symbol. We take micro, the prefix symbol, meter, the base symbol, marry it together, represents micrometer. Nanoliter, symbol for nano, married together with the symbol for liter, describes nanoliter. What I was saying a moment ago is sometimes there's only one symbol. If there's only one symbol, notice over here there's two symbols. If there's only one symbol, it describes a base unit, which means the exponent or the factor of 10 is 10 to the 0. So meter, liter, gram, they're typically described by one-letter symbols, and that tells us, oh, that's a base unit in metric or in international units. Okay, so we'll come back to using this number line. What we're going to do is we're going to take a look at how do we compare metric units. What we have to ask ourselves is, what symbol and factor of 10 is assigned to each? And if we know that, there's a real quick, efficient way to compare one metric unit to another to describe how many times larger it might be or smaller. So here's a gram. We want to compare a gram to a kilogram. Well, if we go back and we look at the metric staircase and we want to compare gram to kilogram, right? Gram has a position. Gram's right here. Kilo is climbing upward. So carparel, 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 kind of like the sound a frog makes when it hops. Carparel, carparel, carparel. There are 3 factors of 10 apart. So that doesn't mean kilos are 3 times larger, or it doesn't mean that base, right, is 3 times smaller. It means 3 factors of 10. This is what 3 factors of 10 means, folks. 10 times 10 times 10. So 10 times 10 times 10 could be written a number of different ways. 10 to the 3, or a 1 followed by 3 zeros. So that's what we can think about for this particular response. 10 to the 3rd, or 1 followed by 3 zeros, 1,000. So let's go back to clearing that drawing. We'll go back to the actual example that I spoke about. A gram is a certain number of times smaller than a kilogram. Well, what we do, or what we can think about, is what is the exponent that, or the factor of 10 that gram represents? 10 to the 0, it's the base. Kilo is 10 to the 3. Well, how far apart would 0 and 3 be? If we're thinking about a number line, they're 3 spaces apart. Remember what we said, that doesn't mean it's 3 times smaller. That means it is 10 to the 3 times smaller, right? Because it's 10 times 10 times 10, or 1,000 times smaller than a kilogram. So this is a strategy for dealing with this. So let's do the same thing with centimeter and nanometer. If we were thinking about centi compared to nano, we could go back to our metric staircase. Centi and nano. Well, let's look at centi, right? Let's place ourselves at centi, right here. Nano is a small unit. It goes down to 10 to the -9. So we'd fall from centi down to nano. Carparel, 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 carparel. We only fell to micro, right? We'd still have to fall 3 more spaces to go from micro to nano. So we fell 1, 2, 3, 4. We'd have to fall 1, 2, 3 more to fall down to nano. So 1, 2, 3, 4, 5, 6, 7. 7 factors of 10 apart using this strategy. So let's clear the drawing. Let's go back to the example. We know there's 7 factors of 10 away from one another. And we're going to take a look at how we do think about that. So we said centi is 10 to the minus 2 on the position of the metric staircase. Nano is 10 to the minus 9 on the position. Well, that's what we said. They're 7 spaces apart, right? 7 factors of 10. So our answer is 10 to the 7, or 10 million, 1 followed by 7 zeros. So this is a really good strategy, a powerful strategy for comparing metric units. Let's do the same thing with millimeter, number 3, millimeter compared to gigameter. So milli compared to giga is what we're looking at. Let's locate milli, right? Milli's right here. So we're going to compare them with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 factors of 10 apart. That's a large jump to go from milli to giga. So 12 factors of 10 apart means kind of like 10 to the 12 apart, or let's go and look at the actual example. So we know there are 12 factors of 10 apart. That helps us with the relationship. So we know milli is -9. Giga, we got that wrong there. We're going to have to pause this and correct that for a moment. So bear with me for just a moment. We'll fix that. Okay, so we've corrected that. So we know to go from -3 to 9, that's 12 spaces, 12 kernel, right? 12 factors of 10. So we could say 10 to the 12, or 1 followed by 12 zeros, right? 1 followed by 12 zeros is a really large amount. So this would be million right here, right? This would be trillion. This would be quadrillion. We don't really need to say quadrillion. Not many people speak that way. So 10 to the 12 times smaller than a gigameter. And our final example, we're going to compare units that relate to storage capacity of maybe like computing devices. A terabyte is so many times larger than a megabyte. Well, tera, if we looked it up, right? Let's look up the factor of 10 for tera. It says it's 10 to the 12, and it says mega is 10 to the 6. So 10 to the 12 compared to 10 to the 6, that's what we're going to do to get this comparison. So 10 to the 12 compared to 10 to the 6, that's 6 factors of 10 apart if we count it on a number line. So we would say 10 to the 6, or 1 followed by 6 zeros. So this is what we mean by comparing one metric unit to another. How many factors of 10 or times larger is one unit compared to another? So it's always related to units of 10. That's the beauty of the metric system. It lets you move a decimal position when you convert. Because if you divide by 10, you move a decimal left. If you multiply by 10, you move a decimal right. And if we know how many factors of 10, we can figure out how many times do we move the decimal left, how many times do we move the decimal right. So let's take a look at the strategy for doing the next skill. So I've revealed some answers here. Let's go back and make it so that answers aren't revealed. Okay, we can work with this. That looks a little better. So we're going to try to take 3,200 meters and convert it into the equivalent kilometers. So what we want to think about is how they're related to one another. We really only have to think about two things. How many factors of 10 apart are they? Because that's going to tell us how many times to move the decimal. The next thing we think about is what direction do we move the decimal? So I have a strategy for doing that. It's a nice quick one. Let's take a look at it. So we want to go from meter to kilometer. We pick out where we're starting. We're starting at meter, which is 10 to the 0, and we're going to kilometer, which is 10 to the 3. Let me show you what I mean by that. So we're going from meter to kilometer. And let's see if we can find that real quickly here. Find it by title. Good. So we're going from meter to kilometer. So here we are, we locate ourselves for meter, right? Meter is the base unit, kilo is above it. So we're starting at meter right here. This is where we're starting. And we're moving upward. We're going to move up, right, to kilometer. That looks like up and to the left a little bit. So we're going to go capital, 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 right? To get there, it's 3 factors of 10 apart. 1, 2, 3. So that actually is how many factors of 10 they're related. That's how many times we move the decimal. What we worry about is what direction. Well, we're making a larger unit. We're starting at base and we're moving up to kilo. When we make a larger unit of measure, the number gets smaller. To make the number smaller, it's showing us here on this arrow, we move to the left, to the left, to the left, move up to the left. So it's kind of showing us left movement right here. We're starting, we're moving upwards and to the left. We're going to move 1, 2, 3 times left. So let's go back to the actual example and move 3 times left to create the conversion, because that's how they're related, 3 factors of 10. So let's see if we can reveal which slide that is real quick here by title, metric conversion examples. There we go. And we're going to make this conversion, right? We said we're starting at 10 to the 0. We're moving to 10 to the 3. That means we take the decimal and we move it 3 times to the left. So we're going to move it 1, 2, 3 times, and we're going to rewrite the value 3.200. The reason I added the zeros on the end has to do with that thing called significant figures. These were significant figures, or these zeros were sandwiched, so I added the 2 zeros on the end. 3.200 has 4 significant figures, just like 3200 with a decimal does. So I kept it the same number of sig figs. Let's worry about the conversion for now. The sig figs thing is sort of a separate idea, but they do sort of go together. Okay, so let's look at 1.5 nanograms compared to milligrams. If you go to your metric staircase, right, you're going to compare nano to milli, and you're going to find out nano has a very specific position. And the specific position for nano, right, is 10 to the -9, right, on the staircase. The position for milli is 10 to the -3. So let's go to the staircase and look at nano compared to milli. So nano compared to milli. All right, here we are. Let's clear any writing we have on there. Nano. Nano's down here at 10 to the -9. We want to get up to milli. So to go from nano to milli, we would go to micro first. -9 to -6 is 3 jumps. -6 to -3 is 3 more jumps. So what we're looking at is to go from nano to milli, we're looking at 10 to the 6th power, or 6 factors of 10 apart. So what we got to remember to go from nano to milli is we're actually moving up, right? Starting at nano, moving up the staircase to milli. And that means, we're going to move to the left. We're going to move it to the left, but now 6 times. So we're going to take our cursor here and we're going to move 1 position left, nowhere to move it. So I got to add 5 zeros so I can place the decimal just to the left of that 5th 0. So when we go to write or record the value, it'll have 1, 2, 3, 4, 5 zeros in front of the 1, 5. This 0 here is really just holding the decimal position. If I left it off, it wouldn't change the number of significant figures, but I put it there so that we know that we're looking at 0 in the ones place. So if you left that off, I wouldn't mark it wrong, right? It would kind of mean the same thing, right? We could kind of think about it not being there. It's still 5 zeros in front of the 1, 5. Okay, let's take a look at a couple more examples. So micro has a meaning or an exponent of 10 to the -6. right? Pico has a meaning of 10 to the negative 12. So let's go back to our metric staircase. We're going to be going from micro to pico now, micrometer to picometer. So by title, slide 43, there we go, from micrometer to picometer. So here we are at micro, right, 10 to the 6, and we're going to fall downward till we hit pico. Well, we'd fall 6 spaces to go from negative 6 to negative 12. So we go, now we'd be falling downward. And when we fall downward, my apologies, I didn't mean to do that. When we fall downward, what ends up happening is now the position of the decimal kind of moves down, but to the right. So now we're going to the right, not to the left, because we're making a smaller unit of measure. And to compensate for that, the number has to get larger. The way the number gets larger is to move it to the right. So we're going to move it to the right, the number of factors of 10 apart they are. In this case, micro to nano. Was it micro to nano or micro to pico? Let's go back to look at the example. As soon as we can find our mouse on here again. There we go. So this one was, micro to pico. So micro to pico, 10 to the minus 6, all the way down to 10 to the negative 12. So that is 6 factors of 10. Now we're falling to go from micro down to pico, falling and down to the right. So the decimal goes to the right, but 6 times. So let's just take a look at how we did that. We moved it once, 1, 2, 3, 4, 5. Nowhere else to move it. Add a 0 to the end, and the decimal would end up after the 0. Now I'm not putting the 0 there because I want that trailing 0, because I want to respect the fact that this was 2 sig figs, so this should still be 2 sig figs. So I left it as a trailing 0 to make certain we had 2 sig figs. Okay, so let's do one without looking at the number line at all. Milli, if we were looking at the number line, we would see it was 10 to the minus 3. Deci would be 10 to the minus 1. Well, let's think about what's happening. Let's clear the drawing up. Let's think about what's happening to go from milli to deci. In that case, milli to deci, that's not right, bro. We're going to have to correct that. So let's just kind of think about it this way. Okay, so we're looking at the metric staircase, and we want to go from milli to deci. And to get from milli to deci, we want to locate them. Right, milli would be located right here, 10 to the minus 3. We're going to go caparnal. In that case, we're moving 2 positions, but we're making a larger unit. So the number is going to get smaller. So we're kind of like we're moving upward, but to the left, upward a little bit. So decimal is going to be moved 2 positions to the left because they're 2 factors of 10 apart. And that's what we're worried about in this particular example. So let's go back and we'll clean up that example, and we'll see that 10 to the minus 3 and 10 to the minus 1, they're 2 factors of 10 apart. We're making a larger unit, so the number better get smaller. And they're 2 factors of 10 apart. We're going to move the decimal twice to the left. So if the decimal was in this position right here to begin with, right, we're going to move it 1, 2 times, and we get 3.6. The reason I chose not to write the 0 there is that would be an East Coast 0, which would be significant. And then this would be 3 sig figs when the original value was only 2 with a trailing 0. So I chose to keep it the same number of significant figures. That really is, again, an independent lesson, but I wanted to make certain that we just sort of mentioned some of my reasoning for choosing to write the numbers the way that I did. So look, until the next time, folks, I'll talk to you soon. This is Mr. Brewer checking out. So always remember to respect the chemistry, but don't fear it.